So let's get started. Anybody that's done any MCP requests in Claude will know this bad joke. Anyway, I'm Jason. Been building with MCP since day one. I did the first Titan memory MCP from the Google paper, created a little framework called Fluent MCP, and did a tooling system called MCPz. Terrible name, really. But I work with clients doing app development, mobile app development, and integrating AI and using AI tooling and building. And I've worked with companies like Blackbox, Emergent, I'm currently working with, and Agentuity with agentic stuff and demos for apps using these sort of vibe coding platforms. And I've appeared on Tool Use and the Robert Scoble podcast talking about some of the stuff I've been building. I'm also a pain in the ass, excuse the language, PR creator on various repos. I got banned from the Goose repo because I did 50 PRs in a day. They thought I was a bot, so I was using AI, but yeah, they let me back in. And I've also done spin-offs of forks of Claudio, Claudable, Kylo Code Desktop, and Open Code Desktop, which I did this week. I also handed over my Claude Code Python package and name to Anthropic for 12 months free Max account, which was nice. And yesterday, Kylo Code gave me some credits because I gave them the package for the NPM, so that's pretty cool. Free inference for a year. So we all know the landscape at the moment. Obviously, we've got models. We've got state-of-the-art models. We've got open source models. Workflow tools. N8, Flowwise recently got bought. LangChain, Classic, and Sim is one of those unknown ones that a lot of people don't know about. It's very good. Tooling, it used to be functions, function calling, function use. We've come to call it tooling, and obviously that's a big part of the MCP protocol, or MC protocol, I suppose you call it. So, you're familiar with computer use, browser use, files, memory, all that sort of stuff. And now, obviously, agents, which has sort of become ubiquitous now with CLI tools, Claude Code, soon Kylo Code, Open Code, Droids, AMP, and many, many others. What I love about MCP, and what I liked about day one, because I had this sort of vision for myself last year of building a development system for myself that could have multiple agents working together or multiple LLMs working together. And I wanted to build it as a modular system that I could plug together like Lego bricks. So you could use each part individually, but if you put them together, they create a whole system. And I'm denied about how I was going to do it. MCP came along, and it was just perfect. So day one, I was building web container MCPs and all kinds of things, just messing around, seeing what I could do with it. We all know, or hopefully you all know, what MCP is if you're here, but it lets LLMs discover and install and create integrations with thousands and thousands of tools that are out there. If you want to add Superbase, add a Superbase MCP. You want to do Stripe, add a Stripe MCP. There's memory tools, there's computer use, there's knowledge-based MCPs, thousands and thousands available. Security is a concern, but it's just like any other system. It's just like any other piece of software you install on your machine. If you're going to install something from NPM, you should take the same precautions as if you're going to install an MCP server locally. And it can be exploited, so you've got to be careful. But its biggest feature is also its biggest problem. What I found out early on playing with it was just the sheer number of tools that you could end up with. And the problem with the tooling is it's got better with some of these services, but essentially, I'm not going to read this word for word, I'll just talk about it. The problem is that its greatest gift is this whole schema that allows LLMs to discover what they can do and be contextually aware. But the side effect and the cost of that is that all that MCP detail goes straight into the system prompt. In the early days, it was the whole thing. So you could say hello to client and burn 20,000 tokens. You still can. And if you do a follow-up, you burn more. And when you're dealing with a context window that could be 128K or something, that's a big deal. And they need to know everything about the MCP servers and tools because they need to be able to read those schemas and understand what they can do. Because you can put tips and things in the descriptions of the MCP schema for an MCP to advise the LLM what it uses it for. But if you've ever used something like Claude Code and then plugged in some other MCP servers or plugged Claude Code in as an MCP, using its server mode into another package, you'll realize that sometimes it doesn't know which tools to use if there's duplicates. So it might have its own file tool to do editing, but it will use Claude Codes. And Claude Code's got a problem, I think it's the grep tool, where it's a massive, massive description for how to use that tool. It's thousands of characters, hundreds and hundreds of tokens burnt for something that you're never going to use, potentially. Manual on-off switches were the solution. Some of these providers did something, I think Blackbox had a thing where they did an MCP mode. So you actually flicked it from MCP mode if you wanted it to include the tools. And a lot of them now in the input area, you can select the tool button and select the tools you want to use. But it's a very manual effort. You've got to do that all the time. And if you forget, you've got to do it again. And there's an unawareness of the job at hand. You know, it's like, I think I've got this later on, but it's like taking a whole tool bag to put a nail in a wall. You don't know what you need, you don't know what you need until you need it. And if you're saying hello and burning 20,000 tokens because you've uploaded all those tools, that's just crazy. So the challenge with all of this is that context, what I call re-engineering, not engineering, is the key to making this work. It reduces noise. You can focus the LLM more on a particular task. It reduces hallucinations. And you can actually eliminate hallucinations if you break it down, enough. And this is an MCP, well, it kind of is MCP related, but Taskmaster is a good example of a tool that's an MCP now, has been for a while, that can break a PRD down into tasks, subtasks, very, very straightforward, focused tasks. LLM gets that task, deals with it, moves on to the next one. There's no overloading of information. And context cleanup is the next big thing, which Anthropic have talked about this week. Going through that context and re-engineering the existing context to remove old tool uses, to remove stuff that's just not relevant anymore. You don't need to know that it failed 3 times, and you can save those tokens and get those back in the context. So the solution I came up with when I was coming across this was to create something that could dynamically provide tooling based on what you were doing. So the way I always went back to it was thinking like Q from Bond, the quartermaster. So Bond's the agent, gets the mission, has the goal, needs tooling, goes to Q, gets the tools that he needs for the job. So it's the right tools for the mission. And I did this concept, which was MCPZ CLI. And the idea is you could add MCPZ as your MCP server via a CLI command, and it would contain a load of MCP servers, and you could create effectively virtual MCP servers with groups. So you could have your Next.js, your Electron, Boo, Tory, and all these different things, and then pull those in to your configuration in your editor, and then your AI will be able to just pull in those things automatically because they're descriptive, it's semantic. So you create toolboxes, you create groups, anything you want, you can group groups. It's all done through the CLI, through a CLI tool. This isn't a cell, by the way, because it's free, it's open source. You can do things like I want to include Claude, but I don't want the grep tool. So you can exclude that tool, which gives you granular control, but it's still manual. You still have to set this up. It can do some automatic detection, but it's a manual process. But you do get immediate savings. So typical usage. So I might have front end, back end, monorepo, Rust, Next.js, whatever, different toolboxes. It's exactly like you would get if you were a DIY person or you were a tradesperson. You're not going to take your entire toolbox, every single tool from your shared garage, whatever, load it into a truck and go off to a job, especially if you don't know what the job is. So you're going to find out the basics, and then you're going to tool yourself up. Now, the practicality of that is you're not going to go back and then get all the tools and come back again. But the point is that you're getting the right tools for the job, so you're much more efficient. So with this sort of concept, you could have a single command in your MCP config, which is MCPZ run, and then pass it actual parameters in the config itself, in the MCP config itself, which means you're able to just quickly go in and say, I want to create a quick MCP server with these 4 tools. Or you could have one MCP server that does all the tools. But you could equally create a load of them and call them different names. And obviously, it's a semantic process. So if you call the MCP server a specific name and the tools a specific name, the model's going to know a lot more how to use it efficiently. But what is the next step of this? So I found by using this that it's a really efficient way of sharing MCP services and tools. There's a service called MCP.run, which is a kind of commercial service. They've got a free tier, I think, and they host MCP servers. So they have MCP servers. You go into an account. Don't work for them, by the way. Others are available. I think Cloudflare have done their own library, and there's obviously a Model Context Protocol official one. But there's many companies that are sort of setting these services up, and then you go in and configure the services, and then you add the MCP server, and you've now got access to all those things. But it struck me one time that I thought one of the biggest things, and it's really funny talking about being lazy when it comes to AI, because I do get lazy with it, and I want everything now. And if I want to spin up an MCP server quickly to do a specific task, it's like, oh God, I've got to ask it, or I've got to spec it, or I've got to write it, or whatever. So I thought about a sort of concept of saying, well, what if I could have a kind of generic MCP server that's like a little script, just a simple script, where I can actually pass it what I need, either in the config or as YAML files or whatever in the repo. So that's when I came up with this concept of MCP servlets. So a servlet is, the idea behind it is it's a generative MCP server. Because MCP, if you're aware of how it works in detail, when you put that command in the config, it's reading it all the time. That's why it knows it's connected or disconnected or it's got a problem. And when it reads it, it gets the tools. You can dynamically serve different tools. So you could serve tools. You can go beyond this concept of get file. You could say get a specific file, get a specific section. You could, that's probably extreme, but you can tailor the tools that are returned based on the job. You can give tools memory. You can have a dynamic tool generated that pulls in information from other places. Maybe asyncs out to a Claude Code instance and pulls out a web fetch and populates some background data in that tool, so that when the model needs to do something, it's like getting a power drill or something and having the manual included and videos all included and how to use it and everything else. It's going to get all that information. Plus, you could feed it with memory about things you've learned using that tool, things that happen, best practice, all kinds of stuff as you go. So it's not a finite thing. It's an ever-changing and evolving tool. It makes it portable. So once you've created that MCP dynamically, which you can do just simply with a script, I'll show you in a second here, you can add that same script to 10 different agents that you use. Now they've all got the same capability. They're all sharing the same memory. We know how that works anyway with MCPs and sharing memory. But what I'm talking about is each tool having its own capabilities, its own memory, its own history, its own tips, its own advice. Really, really detailed tool generation, all in real time. So examples. Let's say you've got a code search tool using Tree Sitter, or you're using a RAG, vector store, or whatever. And you're using a model that's not very big, 128K or something, or 64K even. Now that's a challenge, obviously, with any kind of tooling system because of the size of the system prompt. But with a dynamic system, you could alter that one MCP and that one tool in the MCP based on the resources. So you can get the model to tell the MCP about its environment, what its context window is, what the current context usage is, what the task is, and the MCP can alter its tooling based on those parameters. So for a small context model, or if there's no context left, it might not be able to do it at all. But the minimum it might be able to do is pull up an index of some information or give some dynamic commands back to be able to fetch more detailed records or more detailed line number from this to this in whatever file. So it can dynamically change its parameters to suit the environment that it's in. A larger one, maybe it can take whole files in. And if it's a 2 million one, maybe it can take the whole code base in and go to town. So you create tools for specific tasks. They normally have that sort of underscore format, so they've got weird names, all these things. But TK421 could be a specific task in your taskmaster system or your Gantt chart or your Kanban board. And that task might require very specific tooling. Well, you could go to the extreme and have a tool that's actually based on that task name and includes a certain instruction in it. And in that tool will be all the relevant things that thing needs. It could be the files that it needs to access. It could be the knowledge base it needs to access, the memories and everything else. And speaking of memory, a memory MCP, we're familiar with these. There's quite a few out there. You could alter the memory. You could alter the memory type based on what the job is that's needed from the model. So the model's asked for a certain task. Maybe it's files that are pretty old. They haven't been altered for a while, therefore they may not be in the short-term memory. So you could have it checking long-term memory. You could have it, dynamically serving different versions of the retrieve command. So you don't have to have all that code inside the MCP necessarily in terms of fixing the code. You can literally just say, oh, if it's a file older than then, get it from long-term memory or get it from the code base or get it from somewhere else or whatever. So you're dynamically changing the tooling and results and the schemas and everything on the fly. You could pull in additional information, like I said, with web search, asynchronous agents. I've got a thing where I've got, I can do 8 Claude codes or more. 8's usually pretty much the max to cope, but I could do 8 Claude codes in the same code base with the same repo in the same branch, which is stupid and crazy normally, but they all communicate via hooks in an MCP server that's an A2A server. So they all actually communicate with each other while they're working to lock and unlock files. So they'll say, I'm going to work on this file, I'm going to work on this section, and the others won't touch it. And you get no overwriting, you get no clashing, and you just get these 8 things all processing files and doing stuff, and you come back and there's an app running. It's just insane. Store memories based on tool use, I've talked about that already. And create on-the-fly custom tools from multiple tools. Like, for example, you could create a servlet using this technique, which wraps Claude and wraps its MCP serving to alter all of its tooling to remove the huge descriptions and to optimize that tooling down to a really small context. So you can literally do tool optimization on the fly. Reverse lookup, if that's the right term. So this is a technique where I took an MCP server that actually then serves up a proxy server. So the MCP, you obviously add the MCP in, it spins up a proxy server that then can be used as the endpoint that you can do for your inference, which means you've got, cursor or whatever. Well, cursor's there's a hack, obviously, in for cursor and stuff. You can do it with that. But let's say Claude Code, you can change the base URL to your proxy server, and now everything's going through the proxy, which gives you a much more consistent way to enforce the MCP functions that you want to run. Also lets you create more stuff dynamically, and if you combine that with hooks, it gets even crazier. The other one is an orchestrator app. So with the Claudia app, which is renamed now, I think it's called Odio or something, what I did with that was it's basically an orchestrator of Claude code, so you can run, 20 Claude codes or whatever, whether it's the same code base or not. Normally it's work trees or whatever, but I think they base it on different projects. What normally happens with all these tools, Claudable, Claudia, what's the other one, Conductor, is they're relying usually, I think Conductor have got their own MCP, but normally they rely on the fact that Claude Code's got its MCP configuration. It's got all those tools already. If you make your orchestrator app an MCP host and an MCP server, it's now auto-discoverable on the network to other tools when you add MCPs, but it can now serve tools the other way. And it can add itself as an MCP server to Claude. So now it can create on-the-fly tools for Claude to use, which is really cool. So you give it a task to do, and the orchestrator is now pulling up these 3-4 Claude codes. Before it does this, it adds itself to the MCP config of Claude, and now you've got this crazy situation where Claude's got its own MCPs and MCP tools, but it's now got this new set of tools that could change from task to task or message to message. And you can run that across, Claude Code, XJB. I mean, my example with the A2A thing, I've got Claude Code running with Codex, with Gemini, they've all got the MCP server, which has the A2A. So as soon as they start a task, they register themselves with the A2A server with their name, and they come up with silly names. And now I did one that was based on Star Trek. So it was the Next Generation crew, and they all registered their names and they had their capabilities and everything, and then they all worked together to create something. I even had them doing logs, Stardate logs or whatever. So that's the proxy one there. I've talked about that one. Yeah, so I've used that for things like, you can change the base URL of Claude to point to something else. It's got the Anthropic messages support. And then if you put in that ability to rotate to different models, you can do all kinds of cool stuff. So this week I did the open code. I did open code desktop. I did open code VS Code extension. I don't work for them. And I did a new provider in open code called Freemium. And what that does is goes off to OpenRouter and gets 50 odd free models. And then based on ranking, capabilities, and the tooling and everything, it rotates them per message. So you spread your rate limits across all those models, which means you can use the free tooling of OpenRouter longer. And the same technique you could use, free idea, with Claude. So you could have Claude, Gemini, Codex, and have one proxy server that's splitting across all those different providers, allowing you to, if you use both, you're like me, you use Claude, you hit your limit, you go to Codex, you hit your limit, you go back again. With this, you can spread the wealth, if you like. And you could also include local models. That's the beauty of stuff like that. So with the servlet, this is what it looks like. I've got the repo, I just haven't put it public yet. It's a really simple script, and essentially you add it. I've used the MCPZ CLI name at the moment, but basically you create the message in the config of the MCP, in that MCP config file or MCP JSON file, whatever you're using. So you literally say one of your arguments is the command's MCP. Normally you'd put agents as an argument, create as an argument, and then you'd put the quote, which would be the prompt. And when you do that, it's now created an agent tool which has capabilities and can take context and can take a prompt and can now act, and it can actually talk to itself. You have like a split personality going on where it's actually talking to itself, running in this different mode. You can also do one, I think one of the tools I've got in there is a generic one where the MCP can create its own agents. So there's an example there. Spin up, so this is when I added this sort of generic create agent tool. And then you could just say spin up code review, look at the coding standards, take care of the feedback, continue till it's all resolved, and if you want Claude Code to get involved and delete everything, you can. And it works. The model creates that agent on the fly, briefs the agent on its task, and then the best bit is it replies to itself, because it then replies as that agent, critiques its own code, and then reacts going, okay, I better take care of that. The reviewer's told me to do it, and now it's correcting the code and going back and forth until it's fixed. All created by itself, no code. And that's me done early, which is pretty good, with a minute left. Thank you very much.
Thank you, Jason.